ke saya dah record lah. Okay, tak apa. Dia record ke? Saya tak record lah tadi. Okay. Never mind, tak apa. So you are required to fill in this one, location, laboratory name prepared by student, review by, which is me, and then signature by technician lab, date prepared, review date, and so on. So you need to require to work activities, hazard, which can cause likelihood, severity, and risk, recommended control measures. Okay. And then dia contoh ada bagi kalau 5 ni untuk apa? The most likely result of the hazard even being realized, possible has good chance of occurring and not occurring. So contohnya apa yang you rasa sebagai hazard? Apa yang dikatakan sebagai work activity yang akan ada hazard bila kita datang lab dekat Unitan pada tahun ni? Apa agak-agak ni? So this one is what you need to assess lah before you come to the lab. So, siapa ada idea?
Live wire.
Okay, live wire kalau kita ni. Tapi likelihood tu apa? Apa agak-agak the likelihood? Dia akan masuk dalam apa? Nampak tak sirkuit ni? Kalau kita ada live wire kalau tadi kita bagi contoh live wire. Okay, so kalau live wire is the hazard kan, dia punya ni component. So the likelihood
Might occur.
Might occur. Okay, so it is possible to occur lah kalau kita terlupa nak matikan kan. So and then in terms of severity, what types of severity yang kita akan buat? Negligible. That is depend on what types of life kan. Kalau tu maybe kita kena minor lah kan. Okay. So basically so kalau yang in terms of control apa kita boleh buat? Elimination, substitution, engineering control, administrative control of personal positive PPE. Apa yang kita boleh buat kalau kita nak main dengan live wire ni?
Engineering control.
Engineering control. Is there any mechanism yang you nak control ni? I don't think so. Number 3 tak tepat. Kita boleh guna pakai
PPA kot.
Lagi? Selain daripada PPA apa lagi kita boleh buat? Terus mesti yang satu je.
Elimination.
Yes, elimination. Kita padam je lah power supply tu kan. So tak adalah hebat tu dah. Settle masalah kita. So that's why kita punya tu tak ada serius sangat. Tapi kalau macam nanti you are playing with the live, macam live wire tadi kan. So kita akan dapat 5 most likely and most likable solution lah. And then in terms of ni dia akan serious ataupun 4 lah, 3 or 4. Okay, sebab kalau kita main dengan live wire yang aerial ni lah, and then hazard control yang kita boleh guna ialah personal protective saja. Kita tak boleh buat eliminate. So elimination tak boleh lah sebab kita tak boleh nak potong orang punya kawasan rumah punya elektrik kan. So dia akan cause on the TMP punya ni. And then this risk level kalau yang macam live wire yang tu is high lah. Tapi kalau for us yang tadi live wire in the lab is just maybe low, slightly low risk lah. Okay. So you kena tahulah about that. And then there is also hazard about using the tools macam nak guna paku, screwdriver and so on. So you kena tahulah about that. Okay. So nanti saya tak boleh datang, so at least you need to fill in this one 4 times lah. Okay, untuk masuk bila datang lab nanti. Okay, the next one is the compliance with standard and requirement standards. Okay. So basically you need to understand the symbol and then the standard accompanied with the symbol or the usage. Okay. And everything must comply with act inclusion and comply with the standard from the end user punya and then from the key developer hour lah. Okay. And they are also a zone. For instance, this one is only computer person saja yang boleh main. And then this one the end user or the manufacturer lah yang akan play with all this. Tapi everything must have their own standard to comply with lah. Okay. So macam RCD dia ada dia punya standard, ni ada dia punya standard lah. So kena tahu pada. And then for hospital, they have their own separate standard for their own separate SSO. Sebab tu kalau boleh kita tak digalakkan untuk main ataupun plug in our charge phone to the hospital punya connection, because they have their own separate current requirement lah. Okay, unless it is macam dah crucial sangat, so terpaksa lah. Tapi kalau boleh minta izin dululah kalau semua kita gunakan. Okay, because they have their own separate standard for circuit. Sebab dia ada yang merah, ada yang kuning. Mungkin ada yang for emergency, for the really important stuff, and then dia ada yang menggunakan dia punya equipment, so they have their own separate codes. Okay. Okay, and case 35, protection against electric shock and fire at final distribution board. Okay, so this one, due to this, kita korang adalah diminta untuk ambil gambar you punya distribution board. Okay, nanti lepas habis kelas ni, nanti you ambil lah you punya distribution board, and then take a picture of you punya macam MCB, RCD and semua sekali lah. Okay, kita akan tengok whether you have all the requirement lah. Okay, normally dia akan for the main switch, kita akan ada 63 ampere, 100 milliampere. And then you have a 10 milliampere RCD for water heater or 10 milliampere which is any water heater related equipment lah. Okay. And then for the kitchen, normally is a 30 milliampere which is the SSO, and lighting normally is just 100 milliampere lah, so it's just nice. Okay. Later kita akan tengok balik about this one lah. Okay, so you need to understand about this one. And then for the 4 pole which is the 3 phase, dia ada their own separate guideline lah kat sini. Okay. And then for notes, MS IEC IEC 60364 stated that for RCD electric shock shall have sensitivity of 30 milliampere or less. Okay, so this one kalau nak elakkan shock lah, so normally SSO kita guna 30 milliampere. Okay, and for anything related to water, kita akan guna sensitivity of 10 milliampere in terms of RCD. Okay. And for leakage current, which is more than 260 milliampere or 300 milliampere, this can cause fire. So starting 2015, I think we stop the usage of 30 milliampere sensitivity for RCD. Okay, we allow only for up to 100 milliampere or less sahaja. Okay, or 0.1 ampere lah. Okay, so this is the regulation in 1994. And other than that, they have AC voltage which is less than 50 VRMS and 50 to 60 Hz. And then for safe DC voltage is below 120 VDC or plus minus 10% vapor voltage. So this one is the normal expected safe AC DC punya voltage. Okay. And for any electrical shock that or fire protection, we require a 10 milliampere or 30 milliampere punya sensitivity lah. So the meter is something like this. Okay. So we will use this one to protection against fire. Okay, kita gunakan lah kat sini. And then we have this RC standard, general rules and regulation yang related to this one. Okay, and then we have this registry standard, and then everything can be purchased open source in the web. Okay, and then case 36, which is the protection against overcurrent for final circuit, which is the SSO, sizing of conductor. First, you need to understand the size of connection of the circuit breaker, and then similar to the phase conductor, mutual wire. Okay, so protective earthing conductor, which is by cognition is 1936, and in some cases for the selection, you need to find the suitable cable that you want to buy. Okay, of course you can use any of the selection 1.5 to 16, but the higher or the bigger the size of the cable, the cost will get bigger. So normally we want to find more suitable connection cable for us to buy and to give to the consumer. Okay, kita naklah beli mahal-mahal kan, tapi nanti tak penting pun, tak perlu pun, sebab kalau mahal sangat nanti dia akan berbahayalah, dia akan macam bazir lah. Okay, and then this one for overload current. So this is how kita akan cover ni balik later on, how to step by step. Normally we need to decide, or the consumer ataupun the end user need to decide and tell the what you meant, what type of instrument or equipment that you want to use. Okay, and then ni kita tengok lah, sebab kita kena calculate the maximum demand and diversity factor and so on. Okay, which will cover next week. Okay, sebab kita ada their own calculation, contohnya macam ini, which will cover during the test later. So I hope you understand how to calculate currents. Okay, so contohnya this is one of the question. You are working with contractor register and the company is given a tender for a project for a new residential bungalow, one floor house which supply 3 phase 330. Detail of source is stated below, so this one. So you need to use a diversify factors, and then based on this one you need to calculate the currents. Tahu kan macam mana nak calculate currents? Kalau 36 watt nak jadikan the current, macam mana? What is the formula to calculate?
P equal to VI, sir.
P equal to VI. So kalau check I? So dia jadi P over I per P over V. So P over V lah kan untuk calculate ni kan?
Okay. P over V.
And then macam mana kalau kita ni 1 HP pada aircon, macam mana? 1 HP berapa watt? So you kena tahu lah macam mana nak calculate this 1 HP to watt, how to calculate the 30 ampere and so on. Okay, nanti kita akan masuk balik lah. So maka dia ialah dalam 15. And then this one ada power factor of 0.85 and everything lah. So nanti kita akan masuk this one. So everything ada standard, so kita akan cover later on. So don't worry, kita akan cover. So you need to understand lah, benda-benda ni kita akan calculate. And then from there kita akan calculate berapa banyak fuse ataupun what is the maximum fuse that you can use, sama ada 40 ampere ataupun 63 ampere. And then the section of power outlet nak guna 10 ampere ataupun 30 ampere punya socket outlet. And then what type of MCCB that you want to use lah. So nanti kita kena lukis kat sini lah. Okay, and then dia ada banyak lah calculation of overload protection, sizing of cable and whatnot. Okay, so dia ada banyak benda ni. Okay. Okay, dan dia ada macam ni, ada overload protection of sizing cables, ada percentage. So you need to understand this one lah kat sini kan. So and then conductor in parallel, tak boleh. Kita dalam kita punya, everything must be in series je lah. Dia tak digalakkan in parallel. Okay. So especially for conductors lah. Okay, conductors in parallel is not permitted lah untuk kita buat connections. Okay. And then for voltage drop calculation, we will cover next week too. Okay, there will be a table for calculating the voltage drop. Okay, later we show you one example this week. Okay, short circuit is limiting condition of overload where the fault current is relatively high at kiloampere, and the short circuit potential shall clear the short circuit fault within a short period of time. So we will learn about this later on, about how to protect against short. Okay, and of course the sizing of PE and EB cable is also important when you want to use a 2.5 or you want to use a 60 millimeter square copper. Okay, and then the size something, and the last part I think this case study switch isolation, switching and control. Okay, so you need to shall be 2P or 4P, single phase or 3 phase, 1P or 3P supply power. Okay, and then for isolating, switching and control, you have this one. Okay, not coupling for the providers. So this one, dia punya cable and then the system wiring is slightly different from this one lah. Okay, dia punya MCB is slightly different, so you can understand that part lah. Okay, and then kalau outdoor pun macam mana, the MCB and then RCD pun slightly different. So for RCD, for anything outside atau yang akan ada water, dia akan guna a 10 milliampere punya RCD sensitivity. Okay, and then for factories, normally they have their own multiple layer of protective layers. Okay, so they have their own mechanical, and then they have own mechanical manage start button, and then the own MCB button inside here. Okay, so basically everything yang kita belajar ni, kita normally kita akan conduct a public awareness training workshop and seminars. Okay, and then you are the target audience focus lah. So normally Energy Commission will conduct this every year to make sure that all the wiremen and every electrical personnel knowledge about this safety. So sometimes they conduct booths, but nowadays everything is online, so they can conduct the conference and online talk lah. Okay, they can give you public comment and whatnot to make sure that everybody know their own responsibility. Okay, so this is the module LC circuit configuration. This is connected by IEM engineers, and then this is the per meter voltage drop in terms of length and then the voltage. Okay, single phase less than 11, but more than 11 volt can cause fire, so I think we want to try to avoid this one. Okay, so at the end of the day, you are responsible with your own safety, and if you are the leader, you are responsible to your worker or your working space. Okay, so there are also cases whereby you can survive with the voltage high enough, tapi kalau boleh kita nak cuba elakkan lah ni, terbakar tangan dia, bakar badan dia, so this one dia mati ni. Satu kalau even working macam ni, kita akan ada dua personal lah, satu kat bawah, satu kat atas, to make sure that everybody is safe. Tapi tu lah, kadang dia selamat tapi dia macam ada disability, maybe dia ke otak dia macam tak ada function ke, so dia dangerous area lah. Dan sebab itu juga TNB tak boleh bagi free electricity lah. Walaupun TNB banyak untung dia, tapi TNB tak boleh bagi free electricity due to the risk involved in electrician. Okay. Dan kalau kau perasan, insurance dekat orang yang kerja dekat tempat macam TNB ni, dia punya insurance dia quite high lah. Kalau boleh TNB akan beli yang premiumnya untuk dia punya staff, and then dia punya tu. So in terms of family, memang TNB sangat jaga family lah, sebab dan this one is their own objective lah. Okay, you need to come to work while remembering your family smile. Kita tak nak lah orang balik tak ada dah parents dia kan, so kita kena make sure that you need to treasure the smile of your daughter, of wife or girlfriend or whatever that you have lah. Okay, so kita dah jaga you punya sini. Okay, any question that you like to ask? Basically this is all about the safety dan juga standard related to safety. Ada soalan? Tanya. Ada nak tanya soalan?
Tak ada saya.
Okay. So kali ni macam dia agak mengantuk sikit, so hopefully kita akan buat practical secepat mungkin lah.
Sir,
safety juga. Yes, apa dia?
This question related about last week punya class. Untuk logbook kan, yang company information, yang contractor electric registration itu letak apa Sir?
Letak TNB. Unit 10.
Yang
saya bagi
itu
contoh. Yang tu saya bagi
company
contoh.
name kan?
Yes, company name. Ikut je yang saya bagi contoh tu.
Oh, kalau contractor electric registration pun ikut saja.
Yes, yang tu part tu sebab kita tak ada korang tak kerja pun lagi kan. So that is just a dummy punya part. So kita just tulis sekali sahaja.
Oh, okay. Kalau project endorsement by competent person letak Serafik saja.
Yes,
Serafik
betul.
saja kan? Okay, thank you.
Ada lagi nak tanya? Okay, kalau tak ada, I think that's all for today. Kita stop. And then sebab soalan depan saya ada kelas lagi, so I think we can just stop now. And then kalau ada soalan kita ni, then so tapi ingatlah kau kena ambil gambar you punya DB dan share next week during class. Okay?
Okay, sir.
Okay, Assalamualaikum.
Sir.
Ya.
Pasal ambil gambar DB tu, nanti gambar tu letak dekat dalam logbook tu ke?
Yes, kena masukkan dalam logbook lah.
Okay, sir.
So nanti maksudnya hari ni bila kita check kita punya DB betul atau tak penggunaan DB yang di rumah kita. Kita just check je lah. Tu je.
Okay, sir.
Okay. Assalamualaikum.
Thank you, sir.
Thank you, sir.
Thank you, sir.